Hi, welcome to today's tutorial. Today's topic is high-speed data logging. Let's take a look at the agenda. We're going to start with a data logging review. We'll talk about the functionality and limitations of the standard data logging features. Then, we will talk about high-speed data logging strategies. How can you take samples and measurements that are in milliseconds instead of seconds? How can you record safe position in time with a higher degree of accuracy than normal? We'll talk about dealing with data logging files. We're also going to talk about utilizing the built-in data logger to its full capabilities versus custom programming to take it to the next level. And finally, as always, we'll finish with a Q&A session. Let's start off with the data logging review. Data logging is a feature in Horner's all-in-one controllers. It allows the controller to record machine data as prescribed by the system designer. The logged data is recorded to a CSV file, which makes it easy to import into programs such as Microsoft Excel for analysis. Configuration of data logging is quick and easy. Why is data logging important? Machine users want to extract more information than ever from their machines. They need to validate the process used in the machines to measure their efficiency. They may need to look at the historic operation or diagnostic information of their machines. There are loads of reasons to log data on your machines. Let's have a look at some features. Data log files are recorded to removable media such as an SD card or a USB drive. Data log files are configured as a group of variables, and you can have up to 30 variables in a single group, and up to 100 per application. Readings are taken on a periodic basis at certain time intervals as fast as every second, or on an event basis whenever a particular condition occurs. After readings are taken, especially those that are happening quite frequently, they are then buffered into RAM prior to be written to removable media. Writing to RAM is a quicker process than writing to removable media, which may take a little time. The buffer allows the user to potentially swap out cards without losing any data, as the data is buffered in the memory while the card is missing. Files are created automatically. If your sampling intervals are in minutes or longer, and for trigger-based sampling, then new files are created every day. If you're sampling in seconds, a new file is created every hour. If the file is created every day, the year, month, and day are all included in the file name. If the files are created every hour, the month, day, and hour are included in the file name. You can deal with these files in a variety of ways. One way is to use File Transfer Protocol, or FTP. It's a standard Ethernet protocol that allows you to pull files off of the OCS microSD card so that they can be processed and archived. There are many commercially available FTP clients that support scripting, automatic file transfer, backup functions, etc. Many of these clients are free. Here at Horner, we also offer utility for sale called EnvisionFX. It supports scripting and silent modes, and while EnvisionFX also supports connection via Ethernet, it was primarily created for customers who are utilizing the transfer of data over serial port. FTP over Ethernet is certainly the fastest and most common way to do it, but for customers without access to an Ethernet port, then EnvisionFX is available for them. When dealing with data log files on the OCS, you may want to rename, copy, and delete your files. Removable media functions can be used in logic to perform these functions on files residing in your memory card. Datalog files are stored in a standard .csv format. If you want to view your data logs, you can simply import them into spreadsheets using Microsoft Excel and many other commonly available programs. Now, let's do a demo on data logging. I've loaded Cscape here and I've got an XL4 in front of me. You can see down here in the lower right of the screen, I'm connected to my OCS, which is an XL4. Alright. Let's go ahead and set up some simple data logging. So, let's open the program menu, and then let's select Data Log Configuration. The first step is ensuring that you have enabled data logging as a feature. The next step is to set up some global attributes down here, which I've previously done. You can see that there's a global status register which we use to monitor the status. There's also a global enable variable, which I've just left as always on, so that we are always able to log data. Now later on in some higher speed demonstrations, we'll change that from the always on variable to something else. And for standard data logging, where you're not excessively data logging at an extreme rate, this is a good approach. So, for basic data logging, we want to start out by adding a group. I'm going to call this group process. This is not only the name of the group, but it's also the name of the folder in which the data logging files will be contained for this group. Now that we've created a group, let's go ahead and add some variables to the group. I'm going to keep this simple. Let's grab a temperature value from one of our predefined variables and then add that here. You can add up to 30 variables of different types to any individual group. Once you've added all your variables and your data log file is created, it's time to name them. The column header at the very top is going to be the name of the variable. In our case, its name is already appropriate. Okay, so I've created a group and I've added a variable to the group. Now I'm going to go to group attributes. Now I have the ability to assign a group status register that gives me feedback in terms of how things are going with this particular group. This is an optional feature, so I'm going to leave this blank for demonstration purposes. This here is where we configure what our data logging interval is going to be. So let's just make this every 5 seconds for this test. Data log path is used when you want to log directly to an external drive. You fill in the file path to the drive here. I'm going to leave that blank, which means that the process folder is going to reside in the root directory on the microSD drive. Then we have the option to set our date and time format. I'm going to press OK and then execute this data log. I'm going to go ahead and download to my controller now, which may take some time. So the program has been updated in my XL4 and is currently running, and it should be data logging. So let's see if we can find out if the data logging is happening or not. I'm going to pull up an FTP client. I'm using FileZilla. I am connected to the XL4 and these are my login credentials for FTP. I'm going to hit Quick Connect here. It's going to reconnect with that OCS and do a refresh. Now, I'm looking at the directory of the microSD card and I'm seeing a folder called Process. I'll double click on that and I can see that I've got a file that's named based on the month, the day and the hour. So it's creating a new file every hour. I'm going to download that to my computer. Alright, you can see the downloaded file here. Now I'm going to open it in Excel so that I can view the data in a spreadsheet format. Once Excel is running, you can click File, Open, and then find the file. As you can see, it's successfully logging data. All we have here is date, time, and value, and it's logging every 5 seconds. So this is the standard data logging feature. Let's start taking a look at how we might do things in a faster fashion. Let's go back to our slideshow and cover some of the things that we can do before we start demoing the higher speed option. Now let's talk about high-speed data logging strategies and demos. First, a disclaimer. We're going to be demonstrating how to log machine and process data at rates much faster than every second. If high-speed data logging is really important, use the XL series. The XL4 and up would certainly be appropriate for high-speed data logging applications. Our XLE and XLT are micro series products. Those are our budget products and are great products with tremendous value. They do really well with standard data logging, but when you start to push the envelope for speed, you certainly should be considering our XL4 and up type products in the rest of the XL series. At these sample rates, you cannot sample continuously, you should sample in small bursts. If you're looking for even faster and more consistent rates than we demonstrate, we would recommend getting a dedicated data logger for your needs. Let's talk about how we can start sampling in terms of milliseconds. When using the standard data logging function, the shortest interval allowed is 1 second. However, we can utilize the triggered-only approach in combination with some ladder code or in combination with some special system bits. The OCS has some useful system bits built in, one of which is T100 milliseconds or %S4, which turns on and off every 100 milliseconds. There's another bit called T10 milliseconds or %S3, which turns on and off every 10 milliseconds. For many applications, you may not get the best results using S3, as it is quite intensive. If you want to go as fast as possible using the standard data log type object, you can write some logic that will flip-flop a trigger bit so that you can sample every other scan. Once you start sampling faster than normally, the automatic timestamp in the data log is not recorded in high resolution. However, you can manually set up recording of high resolution time. You can use a timer and add a time base in milliseconds to your data log. Then, you can configure the timer to be non-retentive, so the timer resets to 0 when it doesn't have power. If the duration of the data log is time-based, then we can also use that timer to time the duration of the test, which is useful. And if the duration is not time-based, then it doesn't matter where we set the preset for the timer. Then, you can add the timer accumulator register to your datalog variable group. Now, let's do a demo on high-speed data logging. So we're back in Cscape using an XL4. I'm going to go back into data logging and I'm going to add another group. Okay, we've already got our process group there. I'm going to add a new group called high speed. Back when we were doing our process logging, for global attributes we used %S7 are always on, so that data logging would always be enabled. Now, that works fine for standard data logging, but when you're doing high speed data logging, this may not be the best approach. I'm going to make it so that my data is not automatically logging all the time. I'm going to set up a bit that is going to allow it to start. So, I'm changing the global enable register to have a log start bit now. Okay, so I've created my group, but I haven't added any variables to it. Let's add a single analog variable called pressure here, which is an integer. And to keep things simple, we'll stick to one variable. Then, we'll go under group attributes, and we'll leave the status register blank, which I wouldn't do in a real application, but I will for a demonstration. Instead of selecting 1 second intervals here, let's select triggered logging only. Since we selected that, we now need to fill in the manual trigger register. In this case, I want to go ahead and utilize the T100 millisecond system bit, so I'll enter S4. Alright, so let's just leave it configured that way. What this means is I'm going to be taking a sample of the pressure variable every time S4 turns on, which is every 100 milliseconds. And the T11 bit has to be on as well. Okay, this is going to enable data logging in general. Alright, well let's download that configuration here. I'll go back and hit the download button to the XL4. Okay, so nothing should be happening yet from a data logging standpoint, because T11 is off. Let's have a look at T11. There it is. As you can see, it's turned off, so there should be no data logging happening right now. I'm going to turn it on, and then I'm going to turn it off again. When we're doing our high-speed data logging, we want that to be an on-demand type scenario. Alright, so I should have performed a short data log with a folder called high speed. Let me close this and go back to our FTP client. Let's do a refresh. We now have a new folder called high speed. I'm going to double click on that, and then I'm going to go ahead and download this file. Now, you'll notice it has the same name as the other file I downloaded, so if this wasn't just a demo, I would copy this file or copy the whole folder. Let's copy this whole high speed folder and hit download. Alright, now I'm going to go back into Excel. In Excel, I'm going to open up the high-speed directory and select our file. We have many more readings than we did in the first demonstration. So here is my timestamp, which is at 14:33 and 29 seconds. I only got one sample in during that second, and then it switched over to 30 seconds. Let's see how many samples I got in the 30 seconds timestamp. I got 10 samples within 1 second, and the whole test was 8 seconds. Now we're going to do another test. This time, let's get a millisecond timer created, and let's get that added into another data log. So now I'm going to go back into Cscape. Alright, let's get back to data logging. Now, before we do that, let me show you how to add time in milliseconds. So I've got another section of my main logic here, where I have a timer. So what I've done is I've added a timer with a 1 millisecond time base. I'm going to use this timer to time my tests, and I've decided I'm going to run my test for 1 second. My preset is 1000 milliseconds, and it's a non-retentive timer. Then I'm going to turn on a T1, and when T1 is turned on, this timer is going to execute. It creates a virtual flip-flop that takes a trigger bit and alternates it every scan. While my test is running, this contact is on. Then, if the stored value of my trigger bit is off, I'm going to turn it on. If the stored version of my trigger bit was previously on, then I'm going to turn it off. And this is the logic that I use to record the current trigger status to a bit that I can recall. We can also throw in this accumulator of this timer to get a millisecond value in our data log as well. So let's go back into data logging. I'm going to go into Program Data Log Configuration, and I'm going to add another group. I'm going to call this group Faster. Alright, I'm going to start adding variables, but this time the first variable I'm going to add is going to be that millisecond timer accumulator. That was R1. That's going to be the first variable that I log, and then I can start adding my other variables. I'm first going to add the temperature value, and then after that I'm going to add the pressure value. I'm adding 2 variables so that we have a little more interest in this demonstration. Alright, so my millisecond is going to be the first thing after the timestamp. Then I've got a temperature and a pressure. Let's go into group attributes. Again, for demo purposes, I'll leave group status register blank, and we're going with the triggered logging. Our trigger bit is going to be that flip-flopping trigger bit that I created earlier in logic called trigger or T2. Now that we've fully configured this group called Faster, I'm going to go ahead and delete the high-speed group so we don't have any conflicts there. Now I'm going to go back here under Global Attributes, and I'm going to change this Enable Register back to S7. I'm doing this because I'm in ladder control over this T2 trigger bit. I can start and stop that test on demand, so I can leave this global attribute always on. Okay, so there's the new data logging configuration. Let me download that. Again, this is going to allow us to log as fast as possible using the standard data logging feature. We're downloading that to our XL4. From the standpoint of the new data log group that we just created, it's not actually data logging yet, because that's done on demand. Whenever this T1 test is initiated, that bit is started here. Okay, I've turned on the debug mode, and I'm going to trigger this test. And I happen to have a button on my XL4 that you can't see that I'm going to use to trigger that test with. Okay, so you can see that bit in that test turned on for a second. Alright, I'll go ahead and get out of data log mode. Now, let's go back into our FTP program and see what we see. We need to hit refresh. Now, I'm going to double click on the Faster directory. Here is the file I'm looking for. We're going to download that entire folder. Once that's downloaded, we're going to open up Excel and try and open the Faster file. I'm going to hit File and Open, and once I'm in the File Explorer, I'm going to go back to the data log, find the faster directory, and pull up the file. Okay, so here it is. I'm going to open that up now. Here we have a timestamp with a date and time in seconds. In the next column we have the test timer, which is measured in milliseconds. And then in the columns after that we have temperature and pressure. So now let's scroll down and see how many samples we got in this test. So from 114 all the way up to 2. That means we were able to get 113 samples in a 1 second test. So a little bit faster than 10 milliseconds was a sample speed right there. So that should give you an idea of some strategies that you can use to take samples of your data logs that are much faster than 1 per second. If you would like to record high resolution position, encoders are great for that. An encoder can be configured to indicate both linear and rotary position. The XL series OCS can support up to 2 encoders through the built-in I/O. If you need more than 2 encoders, we have a RCC6512 high-speed coprocessor that can support up to 4 encoders. And we've had plenty of customers utilize CAN open-based encoders that are synchronous. You can add the encoder accumulation register to your data log variable group. Why can't I log every scan? Well, actually, you can, just not with the built-in data log function. It is a completely manual process, and you start by initiating a test like we did in the demos. Then you can write some logic utilizing a shift register to scan every record. The time and the data from a millisecond based timer are going to be recorded in internal registers. Once your test is complete, you're going to use the removable media write instruction to create your log file manually. There are some things to consider if you're logging every scan. If you're using register-based ladder, then you need to use a different removable media, or RM, write block for every different data type to be written. And make sure only one RM write function block is active per scan. If you're using variable-based languages, you can create a single structure consisting of the time and all of your data fields. You can also use the new write RM structure instruction, which will streamline and minimize your logic. Thanks for watching today's tutorial. The Q&A session will begin shortly.
So there you have it. Data logging configuration utility, giving an example of how to do it at high speeds also. We hope that was of benefit to you. I see questions, a couple of questions in here. What is the buffer capacity if the card is removed? Okay, yeah. So the controllers have a 40K RAM buffer, which begins to fill when the removable media is either write protected or removed or absent for any other reason. You can actually view the buffer percent full state in the group status registers. The second register of the group status registers will show you the buffer percent full. So if you remove the card, have a look at the second register of the group status register, you will see the buffer incrementing. Is there a status bit that tells when the memory card is present in the controller? There are status registers, percent SR 174 up as far as 179 or 178, I believe, give an indication of the media card. So it'll tell you whether it's write protected, the status, whether it's there or not, what the capacity is, what the free capacity is. Where can we find this demo video? This demo video will be up on our website, which I will show you now in 1 second. Very shortly after this presentation. It'll certainly be there within the next 24 hours. How many write cycles can be done to a removable media till it becomes defective? Well, that's the removable media limitation. Is it something like 100,000 or maybe more than that? Probably depends entirely on the manufacturer of the removable media, but there is a write limit, obviously, but you would probably get that information from the card manufacturer. Do you have a program code to delete all files older than XXX days, months? Wildcards are supported. No, we're moving now into the removable media function blocks within the ladder. The Datalog configuration utility is exactly what we've just shown. You know, it's all done within the utility environment. But if you start to use the removable media function blocks, then yeah, you can use wildcards to delete files of, you know, a certain year or date or whatever the case may be. So that can be done. Again, when you're using the function blocks within the logic, you just need to be careful that only one of them is active at any time. You can use the current active status register. Just check the value on that, and once it's complete, you can then continue with the next one, etc., etc. Is it better to use USB sticks on devices like EXL6E? It doesn't matter. You know, we can write to either the A drive, the micro SD drive, or the B drive, USB. So that's entirely down to your own choice. How many files can be handled on the removable media? I think that's down to card capacity. Now, I know in the presentation here we spoke about 100 data points, but that's 100 data points within the Datalog configuration, not to be confused with using the removable media function blocks, where you can log as much as you need to. Is it possible to log in some header information like batch data before the data logging starts? With the Datalog configuration tool, utility that we've just done, all of that is taken care of by the utility. If you want to do this within the removable media function blocks, you do need to set up the various strings as part of the logging process. So there's a bit of work in that. Now, in actual fact, I think we have maybe some examples that if you need them, just send an email into tech support and we'll forward those on to you, of showing how to use the logic blocks to create headers for the logged data. Anything else? There's one just popped in there. Let me have a read of that. What if we use micro card and USB at the same time? Can we store something? Yeah, you can store to the A and the B drive simultaneously. That's not a problem. And again, you can, you know, within your program environment, you can actually embed removable media objects on screen for either the A drive or the B drive. Now, currently, you can only view from the system menu. You can only use the system menu to view the A drive. But you can access with those removable media objects embedded on your screen. You can view the A or B drive. So you can do both of those. Okay, I think that's all the questions. Just in case anything else comes in, just bear with me a second. I just want to show you my screen. So, as I see a lot of attendees here who are regular attendees at this point, so thanks for that. We plan on continuing doing these webinars over the next period of time. We've updated our website. So we have on the front of the website, we have a banner with upcoming webinars. Let me just see if we do that. So this banner on the website will show up and coming webinars with the registration dates. And then under support, if you go to support webinars, that'll give you the list of the upcoming ready for registration webinars. Now next week we're going to start looking at serial operations. So on Tuesday next, we will do a serial port operation, which will just focus on talking about RS-232 mostly, some of the standards, and we will demo an ASCII application using a barcode reader. And then on Thursday next, we're going to do an application with a variable frequency driver inverter. Again, just how to set it up, how to set up the parameters, etc., etc. So keep your eye out here. We'd appreciate if you registered using the link to the right-hand side. All of the past webinars, as somebody asked earlier, you'll find them all up here. This one will be live as soon as it's compiled. You'll have it up in the next 24 hours. So they're all here. And if you need any of the demo programs that we went through during the webinars, by all means ask, and we will probably get those resources up on the support site as well. Okay, so again, guys, it's just gone 10 for me. Thanks for joining us again today. I really appreciate it. If we will see you all next week. So until then, take care and thanks.